Hi, Jeff Denworth, co-founder of VAST, who will take a keynote on feeding the thinking machines of tomorrow. Please.
Thank you. Okay. Good afternoon, everyone. My name's Jeff, co-founder of a next-generation data infrastructure company called VAST Data, which you might have heard of. If you haven't, I'm not going to talk too much about that, just because I was hoping to share a little bit of industry perspective. VAST, if you may not know us, we tend to operate with organizations that have extremely scalable challenges. And so today I wanted to bring back a little bit of perspective from that work that we do, and potentially give you a little bit of perspective on what is about to come in the space of AI training, as well as AI inference, as this gets kind of democratized down to the masses, right? And so we're at an HPC and AI conference. Let's talk about some really, really big systems. Systems are getting extremely big in the marketplace today. If I think about the Cadillacs, the big systems that customers have been deploying for some time, if I go back to 2020, the largest GPU systems in production were largely being popularized by organizations like NVIDIA themselves, where they built a reference architecture called Selene that was, at the time, one of the fastest systems in the world. They went and they one-upped themselves in 2022 with a system that had 10,000 GPUs. You might have missed it, but last year there was an organization called Inflection AI. The gentleman who runs Inflection was previously the CEO of the DeepMind division within Google, and broke off to build his own large language model builder company. He now works at Microsoft, and Inflection has a very tight partnership with them. At the time that they came out of stealth mode, they had announced that they built a cluster that has 22,000 GPUs that operate in a data center company and a cloud hosting company called CoreWeave. CoreWeave, for those of you that don't know them, is now operating in Europe and is kind of casually regarded to be running around 10% of the world's GPUs. So fantastically large infrastructure. This in and of itself is a many exaflop system if you measure it on FP16 or FP8. And then this year, there's a much bigger system that has been constructed by the XAI team run by Elon Musk, where they've announced a supercomputer that they built called Colossus. It's 100,000 GPUs in a single network that is deployed in Memphis, Tennessee. And so this is the style of systems that the largest large language model builders now are putting together to start to build not just foundational models, but XAI calls these frontier models because they are well beyond the definitions of classical languages, and these models are now starting to reason. And so if I think about that style of system, right, and I measure it against GDPs of not entirely small countries, you have a level of investment that is just astronomically large. And we see this now starting to also happen across Europe, in particular for training. But regardless of the scale that you operate at, what's becoming somewhat constant across the customers that we work with in the AI space is that they're roughly doubling their investments on an annualized basis as they see a path to value for AI. How do you define it? Well, some organizations define it in terms of business productivity. Others, like OpenAI, are defining value now in terms of revenue, where they're one of the fastest growing software companies in history. Now, that's machinery, right? VAST is a data company. Oh, real quick, just on this one. We talked a little bit about power, and this is becoming a very big consideration. And it appears that only a certain class of data centers will even be able to support these machines, most of which have some sort of nuclear capability powering them. And so what happens is now the entire market is reshaping, where from a data perspective, every solution that comes into the market needs to automatically support the needs of multi-tenant cloud service providers. So everything from multi-tenancy to enterprise data management and protection, and I'll talk a little bit about governance, and maybe even power management, a little bit of a kind of a sidebar here. These systems that are being built next to nuclear reactors, as they hit MPI barriers, then the nukes keep running while the machines stop running for a moment in time. And so either they're putting like very large poles of metal into the ground to to ground these data centers, or they're building very, very large battery stores. But MPI is actually not just challenging people that have, kind of long background in supercomputing, but also is now screwing up nuclear power plants. So anyway, so systems are getting really, really large, right? But data is getting disproportionately larger. For the last 2 years, we've been building some of the world's largest systems for AI training. And you could say that up until this year, most of those training efforts were oriented around text-based chatbots. So GPT-3 was trained on something like 45 terabytes of data. Not very big. This is a year where mixtures of experts and multimodality has kicked in, where people are now realizing that there are AI opportunities around classifying video and creating video and generating video. And then as we work with the really, really big players in the space, they are now pushing towards and talking about regularly artificial general intelligence. And the signature of these organizations as we work with them is that each of them are processing on data sets that are far in excess of an exabyte of data. And so what you have is a 1,000x increase in data growth that we've seen in the space in the last 2 years, obviously propelling a significant amount of business for a company like Vast. And I think on average, you can say as these AI models evolve, I can't disclose all these different large language models and AI models that we work with, but as these AI models evolve, the amount of GPUs that they're deploying and needing is growing, and the amount of data per GPU is growing even faster. And so these two things combine. The interesting thing is that just from the perspective of what type of storage is being used for this data, well, just for the training part, forever the prescription has been enterprise or high-performance computing file systems. This is now also changing in real time, where a lot of the newest transformers are preferring object storage. And so from an infrastructure perspective, you need to plan to support both, from the perspective of researchers wanting different APIs to get to their data. Now, where the data lives is also a really interesting conversation, because forever you think, okay, if I need exabytes of infrastructure, well then I need the cheapest possible medium. Vast has spent the last 8 years reconciling the cost of flash such that you can use it for all of your data. And I'll explain that in our innovation talk that we host later. But power is now becoming one of the biggest challenges in the marketplace, and people say, okay, well, if I just kind of blindly take 2 storage devices, it's very clear to me that that hard drives are better. And the question is that really true? Well, first thing is, if you look at the capacity on this new SSD, today you can buy a 60 terabyte SSD. In a 2.5-inch form factor, what you have is a level of areal density that has now far exceeded what you can get with rotational media. But more importantly, there's another definition of power utilization that comes in when you start looking at how the drives are being used. SSDs use a lot of power when they're being written to, which you have in cases of checkpoints, but when they're being used for archival purposes, or if they're being used for read operations, what you have for feeding a model into a machine or recovering from a checkpoint, there's almost no power. Electrically, these operations are free. And so what you have is a differential of almost 10x per terabyte when you start to look at using these drives for different purposes. So as I mentioned, we're working with customers that are building exabyte scale data sets, and we just went and we did some kind of like standard math. One of the interesting things about SSDs is that people are realizing with random access media, you have more opportunities to shrink down data sets using advanced forms of storage level compression. Now, the net byproduct of that is across the AI models that we're building, on average, you see around 50% reduction in capacity needs because of this new form of compression, which can only be implemented on random access media because otherwise you would completely fragment some hard drives. So the net of it is, when you kind of stack it all up, Whereas if you look at two drives and say, okay, one draws more power than the other, hard drives are more frugal, it turns out that the reality is you need a lot less infrastructure and a lot less power if you consider modern SSD-based approaches to the system. And here we talk in terms of not just kilowatts, but hundreds of kilowatts of savings as customers get into certain levels of data scale. So this is definitely something to keep an eye on. I didn't mention this. End of this year, you'll be able to buy a 120 terabyte SSD. Imagine that. That's like a storage array from just like 3 years ago that you can fit in 2.5 inches. The market is moving extremely quickly. Now, that's data and data infrastructure, but just data and data management I think matters even more. This is a gentleman that comes from OpenAI. His name's Jim Bettker. And Jim wrote a blog post a few months ago about the essence of AI infrastructure, whether you're talking about a model that you've foundationally trained or that you've fine-tuned. And basically what he said is that if you take the same data set and you put it against any of the kind of popular model architectures, and you train those models with that data set enough times, the expression of that model, ultimately all those models converge to the same point. The point being that data, more than model architecture, defines how we will implement AI in the future. And so when you see a model, you're actually seeing the data set that it was trained with. And it makes sense, right? These things are trying to approximate and understand reality. Well, first off, if you're going to be training, and the first thing that you need to do is prepare that data such that it is appropriate for this. Now, if you look at NVIDIA's reference architectures for building large-scale training infrastructure, they only really focus in on here, and they assume that all of this work has already been done. We, of course, know that this is a very complex problem with large pipelines that need to be serviced by a lot of different tools, right? Earlier, when we heard the talk from the E4 Analytics team, there's a whole suite of enterprise tools and developer tools that are needed to build AI pipelines. And this is a very different world than how scientific computing has worked previously, where different teams from different research universities would kind of come up with an idea and drop some software into GitHub. Now it's totally different, where there are standards and there are processing frameworks. A lot of this is done in Spark. A lot of this is done in Python, and you use file systems. And then, of course, when you inference your data, then there's a whole other raft of complexity. But the interesting thing is that this is a whole big problem that nobody sought to address until VAST. And I invite you to go to our technology innovation section that we're going to be hosting next. But if I think about that, first of all, I've got the importance of data in that it defines my model. Second is the complexity of building that model through a complex data pipeline. Third is how do I handle governance, right? And the AI Act basically says, okay, well, you need to be able to collect, document, and analyze all the relevant data that comes from that inference operation. And data becomes part of your code as you go and train on that. And so all of this is a level of kind of thought that needs to be put through building pipelines where not only do you need massive scale, but you also need processing infrastructure, not just storage infrastructure that can make sense and curate and help you analyze this data. Number two is if that data set defines the model, that is the most valuable part of your AI effort, right? OpenAI is about to be worth $150 billion. That means the data set that's associated with ChatGPT 5 is worth about $150 billion. And so you want to make sure that you have the right controls, the right auditability, and the right even ransomware protection on that data set, because it is absolutely critical. And then third is you need the right tools for compliance and feedback. And this is not how the HPC community has been building data infrastructure at all for the last 5 to 10 years. And it is also the basis for why VAST is now becoming one of the most fastest growing companies in infrastructure history, is because this is the stuff that we think about. And so data's soon going to really matter. If you watched Rod's talk, he talked a little bit about RAG, or retrieval. And what's about to happen in the marketplace is context is going to be layered on top of all of the data that we already sit on today. AI models can't be trained with a certain amount of data because ACLs don't go through the models. And so the idea of retrieval is, okay, if there's information that a model shouldn't generally have, it can go off and get some separate data from some separate data source. And that data has already been contextualized by another AI model, which is called an embedding model. And so we approached this whole topic by saying, first, let's build a new foundation that everybody can compute on. Let's open up access to data. But the reality is, the whole time that VAST has been working, we've been waiting for this moment. This moment where you could now have AI make sense of your data. The term unstructured data simply implies that I have no clue what's inside of it unless somebody's manually gone through and collected that insight and put it in some separate data set. Structured data is very well understandable. You can query it. It's super simple. And for the first time in human history, you now have a machine that can make sense of the largest data sets that we've been sitting on that we have no understanding of. And so the future is going to be very different from where it is today, because I would argue that there will be no definition around unstructured data in the future. Everything's going to have structure because of AI embedding models. Everything will be queryable either through SQL or through some vector databases. And ultimately what's going to happen is traditional file systems will have to die because they don't know how to naturally support the needs of AI agents. And so some people call this a file system catalog on steroids if you have the entire context layer. But ultimately what's happening is we're working very hard to make data conversational. You should be able to take an agent that is a large language model and just ask a question and get an answer to all of your enterprise data. And this becomes the thing that really democratizes AI across a business. And that's our whole story. So we also do HPC really well, by the way. And VAST has been on kind of a real tear. We've built an amazing organization. We're just starting to work in Italy. And we've been fortunate to work with some of the best partners in the world. And we invite you to learn more later. So thank you.
Thank you. Thank you very much, Jeff.